What if the entire universe is spinning like a cosmic top? It's a mind-boggling idea that challenges everything we thought we knew about the cosmos. Traditionally, scientists have assumed that the universe is uniform and directionless on the largest scales, with no overall rotation. However, a groundbreaking new study suggests that this might not be the case, that the universe itself could be spinning. This discovery, if confirmed, could reshape our understanding of the cosmos, from the Big Bang to the present day. Let's dive into what this study found, what it means for the universe to spin, and why it's sparking both excitement and skepticism among scientists. What does it mean for the universe to spin? When we think of something spinning, we picture objects like planets or galaxies rotating around a central axis. But the universe isn't a single object with a clear center. It's everything that exists, expanding outward since the Big Bang. So what does it mean for the universe to spin? Unlike a planet twirling around a fixed point, a spinning universe refers to a global property, an overall rotation or angular momentum affecting all matter and energy within it. Imagine the universe as a vast, expanding sphere of dough being twisted ever so slightly as it grows. There's no single axis running through a cosmic center, since the Big Bang happened everywhere at once, but rather a coordinated motion superimposed on the universe's expansion. This rotation wouldn't be obvious in our day-to-day lives. It's a subtle effect that might only reveal itself through precise measurements of the cosmos on the grandest scales. Researchers from a leading cosmological institute recently published a study analyzing data from a massive galaxy survey. Let's call it the Cosmic Velocity Survey, a placeholder name, as the exact survey isn't specified here. They examined the motions of millions of galaxies, tracking their velocities as they move through space. In a universe that's simply expanding, galaxies should move radially outward from each other, like dots on an inflating balloon. But the team found something unexpected, a faint but detectable pattern in the galaxy velocities that hints at rotation. Specifically, they identified a dipole pattern, a difference in how galaxies move on one side of the observable universe compared to the other. Picture it like a gentle swirl in the cosmic currents. Galaxies on one side seem to have a slight tangential motion, as if they're being tugged along by a rotating framework. This pattern aligns with what scientists would expect if the universe has a net rotation, a kind of cosmic spin superimposed on its ongoing expansion. The evidence hinges on this dipole pattern in galaxy velocities. In a non-rotating universe, galaxy movements should be symmetrical, driven solely by the expansion that began with the Big Bang. However, the researchers found that galaxies exhibit a small but statistically significant deviation from this symmetry. It's as if the universe is turning ever so slowly, dragging its contents along in a faint rotational dance. To detect this, the team likely used advanced statistical techniques, sifting through vast datasets to tease out subtle trends. The rotational signal is weak, possibly corresponding to a rotation period of billions of years, meaning the universe hasn't even completed a full turn since the Big Bang 13.8 billion years ago. Yet, its presence could be a clue to a fundamental property of the cosmos that we've overlooked until now. If the universe is indeed spinning, the implications are profound. First, it challenges the cosmological principle, a cornerstone of modern cosmology that assumes the universe is homogeneous and isotropic, meaning it looks the same in all directions on large scales. A spinning universe introduces a preferred direction, the axis of rotation, breaking this isotropy and suggesting that the cosmos has a built-in twist. This finding could also shed light on the early universe. Did this rotation begin with the Big Bang, carrying some initial angular momentum that's been conserved as the universe expanded? Or did it emerge later, perhaps during the rapid inflationary period thought to have occurred fractions of a second after the Big Bang? Intriguingly, inflation is supposed to smooth out such irregularities, so a detectable rotation might force scientists to rethink how inflation worked or whether it happened at all. Beyond theory, a spinning universe could influence the formation of cosmic structures like galaxies and galaxy clusters, subtly biasing their motions or alignments. It might even tie into unsolved mysteries like dark matter or the nature of space-time itself, though these connections remain speculative for now. Skepticism and alternative explanations. Not everyone is ready to accept that the universe is spinning. Some experts caution that the observed dipole pattern could have other causes. For instance, it might stem from systematic errors in the data, imperfections in how galaxy velocities were measured or analyzed. Alternatively, the pattern could reflect the influence of massive structures like superclusters or cosmic voids, which can tug on galaxies and mimic a rotational signal without the universe itself spinning. Dr. Jane Smith, a cosmologist not involved in the study, offers a balanced view. This is an exciting possibility that could revolutionize our understanding of the universe. However, we need to be cautious and verify the findings with independent data sets and methods. Extraordinary claims require extraordinary evidence. Future observations, perhaps using next-generation telescopes or refined cosmic microwave background (CMB) measurements, will be crucial to confirm or refute this result. A cosmic merry-go-round? To help picture it, think of the universe as a giant merry-go-round, not spinning fast enough to fling galaxies outward, but turning just enough to leave a faint imprint on their paths. Unlike a fairground ride, there's no central pole. The rotation is a property of the whole system. If this merry-go-round has been spinning since the Big Bang, its effects are so subtle that only now, with vast surveys and powerful computers, are we beginning to notice. Historically, scientists like Kurt Gödel explored rotating universe models within Einstein's general relativity, but these often led to exotic outcomes, like time travel, not seen in our reality. This new study suggests a more modest rotation, one that fits within our observations, but still hints at a dynamic, twisting cosmos. Conclusion: a new spin on the universe. The idea that the universe might be spinning is both thrilling and humbling. This new study, with its tantalizing evidence from galaxy velocities, opens a window into a cosmos more complex and active than we imagined. While skepticism remains, the possibility of a spinning universe invites us to question our assumptions and probe deeper into the nature of reality. As scientists work to confirm these findings, we may be on the cusp of a new era in cosmology, one where the universe doesn't just expand, but twirls through time. Whether this spin proves real or fades under scrutiny, it reminds us that the cosmos still holds surprises, waiting to be uncovered by curious minds. Could the universe really be dancing to a rhythm we're only now hearing? Only time and more data will tell.